Hey everyone, welcome to 4.5 Integration by Substitution. Really what you want to do is recognize the pattern. A lot of this stuff is going to be a little bit difficult until you can recognize the pattern, so just doing a bunch of problems and knowing what goes where and all that kind of stuff really helps. So if you know the chain rule really well, you have to apply that backwards really for integration by substitution, because that's what's going to happen, because it's not always going to be such easy derivatives as we've had. Okay, so let's really just jump in. This is going to be the first video that we have, and then we're going to get into the next one with U substitution. But right now we're just going to do with f's and g primes and all that kind of stuff. So here is theorem 4.1, anti-differentiation of a composite function. So that means we're going to have f of g, right? So we got all this stuff, and you kind of see what it looks like down here. So let's just go ahead and read it. So it says, let g be a function whose range is an interval I, and let f be a function that is continuous on I. Notice how everything we've done is continuous, differentiable, all that kind of stuff, because if we're going to anti-differentiate, we have to make sure that it's continuous, otherwise it won't make any sense. If g is differentiable on its domain, and capital F is the antiderivative of lowercase f on I, then the integral of f of g of x, g prime of x, dx equals capital F of g of x plus c. And then also we say if u equals g of x, then du equals g prime of x, and integral of f of u du equals f of u plus c. So these are kind of two different cases. We're going to do the top one first, we're going to do the bottom one second, and you can kind of say which one do you really like to do better. The bottom one's more known as U substitution. There may be some other names. I don't know what's out there, but I'm sure that if you wanted to, you could find it. Okay, let's now go through and do an example. Not example 2, let's do example 1. Here's example 1. It says evaluate the integral of x squared plus 1 squared 2x dx. Alright, so we've done 1, and what we had done before is if there was a plus, then we said, okay, let's just separate those out and do them separately as two separate, I keep saying that word, separate integrals. However, that doesn't work with multiplication, so we're going to have to do something else. So I kind of highlighted it in red here. You might be able to see it. You might not. But that whole thing, what we're going to say is that's going to be our g of x is going to equal x squared plus 1. Okay, now you say, why is that g of x? Well, because you take this whole thing, this whole function, and we're going to square it, right? So we can really say, like, f of x is going to be like x squared. Okay, now we don't really need to write that down. That's not a big deal, but we're just saying that's like this whole thing squared, and then we shove this function right inside of it and say, okay, now it's going to be x squared plus 1 squared times 2x dx. Okay, so we're just going to say this whole thing inside is going to be x squared plus 1, and that's our g of x. So what we're going to do is, what happens if we take g prime? G prime of x, if I take the derivative of all this, well, that's just going to be 2x, and that's it, right? Well, notice how this 2x matches up with that, and this thing matches up with that, and that is exactly what we need for this whole thing, right? Because if this is the case, if we have f of g of x times g prime of x dx, then we can just say that's the integral of f of g. Okay, so really we just have to find the integral of this thing. So we can say f of x equals, well, now how do I find the integral of this? Well, I know it's x squared, so it means I have to bring it up a power, right? So it should be x cubed, but instead of having it x cubed, I should have it as 1/3 x cubed. That way when I go backwards, I end up with just the square, correct? Okay, good. So then what we could say is, if I want to evaluate this whole thing, I can say that equals 1/3 of x cubed. Now instead of this x, what is going on inside of it? Remember, we're putting g of x in that spot, right? So we're going to say that whole thing cubed, and then this g of x is going to go down in there. I'm just going to use a different color here, what the heck, to plug in g of x. That way you can kind of see where everything is coming from. And it's still, notice how in the formula, it's g of x and it's g of x. So we don't have to like take the derivative of that g of x to make sure that it all works out, because we kind of took care of that with that 2x. All right, so we have the x squared plus 1. And then what is the one thing you always have to remember that I hope I always see on your papers? Maybe I can use some sort of other help with this. Maybe if you know the Spanish word for yes, or the word in Spanish that says yes, that's correct. It would be plus c, because we have an indefinite integral. We aren't differentiating or integrating on a specific domain, so that way we don't know what numbers we have, so that means we have to do the plus c. Okay, so we're going to be done. That should be our answer. Now, what you should always do is you should just check to make sure that works. Alright, so let's just check to make sure that works. So I see this cube first. Cube times 1/3, that's going to all cancel out, so I'm going to have x squared plus 1 squared, and then what I have to do is I have to take the derivative, the derivative of the stuff inside. Well, that's just x squared plus 1. Derivative of x squared is really just going to be 2x. And then that would be that derivative of my original function that I had. Well, does this thing match up with what I had up here? It absolutely does. It looks exactly the same, which tells you that I did it right. Now, here's a very pro tip for you. Integration is hard. Doing this is not easy to see, and you do have to recognize the pattern and hope that it works out. What's easier to do is the differentials, right? Differentiating this without the c is a lot easier to recognize and say, okay, the 3 goes here and then to multiply by the stuff inside. It seems to make a lot more sense in your brain, at least in my brain. So therefore, what I do is, especially early on, these first few examples, the first stuff that I'm doing, I'm going to do this every time, because I know that I can't just do the integral in my head and be able to get the right answer all the time. I can probably do this in my head and kind of check, oh yeah, that works out, or oh shoot, I made a mistake. Even if I have to write it out once, it shouldn't take too long, and it'll probably stop you from making some silly mistakes later on. Alright, so find the answer, take the derivative, just make sure you get back to what was after the integral sign. Okay, so let's move on to here to example number 2. It's the integral of 5 cosine 5x dx. So we could move that 5 out in front. Sure you could. But let's just say that g of x equals that 5x. We can say that f of x is going to equal the stuff that's in front of it, right? You can say like that's the f of x. F of x is going to be cosine of x. Now, I could probably use a different letter than x, but I'm using x for now. Okay, and then what is the derivative of 5x? Well, g prime of x is going to equal 5. And that's that thing right here. So we can say that's g prime of x. We can say this thing is f of x. And we can say this thing is g of x. Right? So we can say g prime of x is that 5. So we better keep it. F of x is going to be this whole cosine function, and g of x is the stuff that's after the cosine. Okay, so I've got the g of x. I've got the g prime of x. I've got the f of x. Let's find f, the capital F of x, right? There we go, a capital F of x. Well, what's the antiderivative of cosine? Well, I'm going to go back and look at the front of my book because I don't always memorize those things yet, even though I probably should. And if I just find cosine, the derivative of cosine is going to be negative sine. So, let's find negative sine. Okay, it's positive sign. It's sine. It's sine. Sine, sine, sine. Right. So the derivative of cosine is going to be sine x. And let's just do the plus c, right? And that this is a capital F, which means I took the integral of that whole thing. All right. Good. So we've got the g prime and the g. That kind of stuff cancels out, so I should be able to write my answer as sine of 5x. And then I'm going to write it out as that. I should have put that in a different color. Sorry. Plus c. Don't forget the plus c. And then we say, okay, is that right? Did I do a good job of that? And I can say, okay, well, let's take the derivative and see what happens. What's the derivative of sine? Well, I know that's going to be cosine of 5x. And then what's the derivative of 5x? Well, that's just going to be 5, right? And then that's just going to be the same thing as what we have here, just kind of rearranged, and we're all done. There you go. So again, a good idea just to kind of check. Right? Square my answer, put a square, rectangle, cube, whatever you wish to call this thing, around my answer, and that's my check to make sure that I did it right. Okay, very good. Here's the last example we're going to do. Evaluate x squared plus 1 squared dx. Okay, so we're going to say I see two things multiplied together. I'm going to see what I can do. Well, I've got this whole thing squared, so I'm going to guess that my g of x is going to equal x squared plus 1. I'm going to say that my f of x is going to equal this whole thing squared, so I'm just going to say it's x squared. Should really just give you a different letter. It's probably going to be easier. Okay, well, anyway. Now I've got g prime of x is going to equal, the derivative of that is going to be 2x. Okay, so I've got the x squared plus 1 right here. There's my g of x. I've got this whole thing squared. Let's use a different color. That is my, right here, this whole thing is the f of x. And then this last part, x, is my g prime of x, but it's not quite g prime of x because I've got a 2 there. So, and I only have an x there. What do we do? Interesting. Now, could I multiply by 1? Of course. Now that should be a hint, because multiplying by 1 is the way to go. Remember how we multiplied by 1 to like complex conjugates, or just multiply by conjugates to get rid of radicals or i's or that kind of stuff? We're going to do the same thing, but we want to get rid of the 2. So I want to multiply something by 2 to get to 1. So really what I want to do is I want to multiply by 1/2 and 2, because 1/2 times 2 is going to equal 1. So if I multiply by 2, I'm going to be A-OK. Alright, so let's go through and let's try it. So I can say this is going to be the integral of, let's just do 1/2 times 2x, okay, times, I'm going to put this in red, that way I know it's going to be the f of x squared, good, and then my g of x is going to be x squared plus 1, and then we have that d of x at the end, dx at the end. Okay, so there we go. Now, because I have a number in front, a constant, remember what we can do with that constant? We can pull it out and put it out in front. It can just sit out in front. That doesn't matter, which is so helpful before you're saying like, oh, so what? Doesn't really matter. We can just use it or not. But now I can get this 2x to be out in front, so I can manipulate this equation actually this expression. I can manipulate this expression enough to get it to be a 2x if I don't have one, right? I can't do that with an x. I can't change it and say, oh, multiply by an x squared and put 1 over x to kind of cancel some of those things out. That's not going to work, but I can do it with just constant numbers. So I can rewrite this as 1/2 integral of, let's just do it in some more colors, 2x parentheses squared of the x squared plus 1 squared times dx. Okay, good. So now everything matches up real nice. Yes, it does. So now what I want to do is I want to take the integral of little f of x when it's x squared. So I can say that's going to equal 1/3 x cubed, right? Okay, so then the integral of all that stuff is going to equal, I still have the 1/2. This integral and all that stuff is going to go away. I know I'm going to have 1/3 times something cubed, and that stuff that's inside is going to be my g of x, which is x squared plus 1, and then don't forget, plus c, write it in now. And this is all multiplication, so let's make this just a little bit better for our solution. And I should get, I'm going to write it all in one color to save some time here, 1/6 x squared plus 1 cubed plus c. Alright, so you should be able to check that on your own, see if that works out. There you go, and that is it. We are all done with this video. Check in soon for U substitution. Good luck!